Well, hello there once again. It is KP the Math G, and I did as promised. I was going to give you something that was from one of the tests. Now, I've had this in waiting for probably about 4 weeks, but I wanted to go ahead and cover those volume of revolution videos, and there were about 3 or 4 of those. So I got those done, and you can look at those at your convenience. But I have a nice little problem for you, and it has to do with reviewing implicit differentiation. So we're going to, in this first one, this one is from the 2004 test. Q means question. Question number 4, this is a free response question, and there were 3 parts to this, but we're only going to do the first 2, and then in the next video we will finish off doing the last one. Alright, without further ado, let's go ahead and let's look or examine this question. It says consider x squared plus 4y squared equals 7 plus 3xy. Show, I'm going to make sure I copied that down correctly. And yes, I did, yes. Okay, show that dy over dx, taking the derivative of this, in other words, is equal to all this. Alright. Alright, well, we're going to prove it. Proof. Alright, PF, proof. Alright, so right here, I'm going to prove, I'm just going to take that, you can do this. Alright, remember every time you take a derivative of y, you take that dy over dx. Some people put y prime there, and that's okay too. Alright, so here we go. This one is 2x. I'm going to need a different color. I have a feeling that my pens are running low on ink. And I think of the quite few that I have, I can do a full lesson on this one, on the ones that I do have. Okay, so here we go, dy over dx. Alright, so we got to take this 2, this is 2x. Alright, so plus, alright, 2 times 4 is 8, 8y. Now we took derivative of y, so tack that dy over dx on the end. There we go. Derivative of a constant is 0. Alright. The derivative of 3xy, well, this is the product rule. So the derivative of the first, so that's 3x, which is just 3, times the second, so 3y, plus the derivative of the second, which is 1 times dy over dx, alright, times 3x. Alright, so that one is the product rule. Alright, so the derivative of the first times the second, there it is, plus the derivative of the second, well, that's going to introduce that dy over dx times 3x. So let's rewrite a little bit of this. We have 2x plus 8y dy over dx, alright, is equal to 3y, alright, plus, and we can make this 3x dy over dx. Alright, I believe that's everything. Now what? You got it. We got to get our dy over dx is on the other side, and our x is on the other side. So let's see, it's looking pretty good so far. So let's go ahead and move this over here, minus 2x. So let's just put it up here, minus 2x. This is gone, so now we've got 8y dy over dx, alright, equals 3y, I'm just going to put, okay, so plus 3x dy over dx minus 2x, x, 2x. Yes. I want my x looking like a y at this stage in the game. Okay. Now simply divide both sides by all of this. So if we do that, so if I divide this side by, well, no, let's see, subtract it. I'm not dividing. Oh my goodness. Alright. I'm not dividing. I'm doing the opposite of plus, which is minus, right? Alright, so minus 3x dy over dx. I'm just going to put these two together and factor out that common one over here. So we've got it right here. So 8y, now let's see, 8y minus 3x. Oh, I need some more room. Let's put it up a little bit higher. Let's put it on up here, matter of fact. Let's go. Alright, so 8y minus 3x, I just factored that out, times dy over dx is equal to, alright, that's gone, 3y minus 2x. Okay, I think we can bring it down here now. If I divide both sides by, alright, so let's see, 8y minus 3x dx, I'm going to divide both sides by that. Okay, and that's equal to 3y minus 2x over 8y minus 3x. Okay, and of course if I cancel that out, now I'm saying dx, dy over dx, okay, right there. Well, let's just put it like this. Let's just say this is all this dy over dx right there. There we go. I only did that because I ran out of room there. Okay, that leaves this by itself, doesn't it? So that's all you're doing is solving for dy over dx. Once you take that derivative of y, you take that dy over dx or y prime, and now you've got dy over dx, and it's what we've got. 3y minus 2x over 8y minus 3x. There it is. 3y, make that a y, make it a little more clear. 3y minus 2x over 8y minus 3x, and that's dy over dx. Okay, you got to show that. You got to show your steps in getting there. Okay, which that's pretty obvious. It is you know, just practicing up on your finding the derivative by implicit differentiation. Okay. Alright, there it is. Good news is, guess what? We'll have to find the second derivative. Well, what rule would you have to do if you're going to find the second derivative? That's right, the quotient rule. Okay. Alright, we'll worry about that in another video. Let's flip this over now. We've got the second part right over here. Alright, now what they're saying is we want to show that there is a point P with an x coordinate 3 at which the tangent line, alright, so that point is on the tangent line to the curve. The point is both on the curve and on the tangent line, and it is horizontal. So, and it's asking for what is the value, what is this, alright, ordered pair. Well, we know that the x value is 3. Alright, we already know that. We just need to find that y value, don't we? Okay, so what we just did a while ago is we found the derivative, and I've already got it written down. Or let's see, we found that dy over dx, we found that to be equal to 3y minus 2x. Actually, we proved it or showed it is equal to 8y minus 3x, like that. Alright, now it says, so what we're trying to see is this, let's say that, I don't know what, let's say maybe this is point P and there's a line going through there. That point 3, it's 3 comma something, okay, and it is tangent to the curve. It's horizontal. That means that the slope is equal to 0. So if it's horizontal, we know that. Alright, that's what they're wanting you to see. Now there are many slopes, but we want the one where the slope is equal to 0. Alright, so let's do that. They could have said equal to 1 for all we cared, but we want the one where the slope is equal to 0. And if it's horizontal, the slope is equal to 0. That's the point. Alright, so the slope m is equal to 0 because the tangent line is horizontal. Alright, that's what we're talking about. Alright, so we're going to set this derivative, because that represents the slope of the tangent line, doesn't it? Okay, so 3y minus 2x over 8y minus 3x is equal to 0. If we were to multiply both sides by 8y minus 3x, we would just be left with the numerator. And kind of keep that in mind. So if we multiplied by 8y minus 3x, assuming that this is not equal to 0, alright, times 3y minus 2x over 8y minus 3x, alright, all that, sorry, okay, right there now, alright, right there, now that equals to 0 times 8y minus 3x, alright, which is, that's 0, and this divides out, so now this is really 3y minus 2x equals 0. Alright, we have two unknowns. Actually, we only have one unknown because we already know what the x value of this is. X is 3, so we just need to find what y is. So 3y minus 2 times 3 is equal to 0. So what we have here is 3y minus 6 is equal to 0. Alright, we're going to add 6 to both sides. Alright, so 3y is equal to 6. And then when we divide by 3, then y is equal to 2. Alright, so the y value is equal to 2. Alright, so 3, 2 is that. We can show that this is equal to 0. Let me erase this. Alright. It helps to know that that x value is 3, right? Alright, so in seeing that, we can just simply plug in the 3 and the 2. And so let's see. 2 is y and 3 is x. Okay, minus 2 times 3. Alright, right there. Over 8 times 3. Alright, 8 times 2 rather. 8 times 2 minus 3 times 3. Alright, so what we have here is 6 minus 6 16 minus 9, so 0 over 7 is 0. So that shows that the slope is indeed 0 at that point right there. The slope of the tangent. Well, that's what we found in the first place, wasn't it? Okay, so I don't know if you have to show that. You may want to ask your instructor about that part of it, but you definitely need to find the y thing, the y value here. You have to show that the slope is 0 because the tangent line is horizontal. Okay, that's what you got to at least say something to that effect. That makes this slope equal to 0. If you show that, I'm sure you're going to get the points for it. And if you plug these in, that actually proves that that slope is indeed equal to 0. So we found this value right here, 3, 2. And so again, on the first one, all you had to do was show. If you know how to differentiate implicitly, you're in good shape. If you don't know, look at this video and you got it right here. You can show that. That's pretty simple to do if you just apply yourself. Remember, when you take the derivative of y, you're tacking on that dy over dx. If you take the derivative of x, no, you're not. Okay, so that's that one. And then on this one here, yeah, that's really what you have to show right there. Okay, there is a point P. Yes, there is. We showed that right here. We showed this right here. Okay, and we definitely knew that this was the slope of the tangent line, and we solved. Actually, we just solved a while ago, and we found that y value to be equal to 2. Alright, there it is. And that is all I'm going to show for today on this one. There is another part to it, and I just don't want to jumble everything up at one time. I think it's just too much to try to jumble everything up. So I think this will be alright. And we probably could do this, the third part, but it's going to take a little bit more time. And my old camera, I don't know if it will continue to run throughout the entire rest of the time, because after about 30 minutes, I think I can go up about 32 minutes, and that's about it. And I'm trying to make these videos a little bit shorter so that you don't get bored or something like that watching these, okay, and that you get the full effect of what this is trying to show. And by the way, keep in mind, for you AP students, this was a good question, wasn't it? See what I mean? A little bit of refresher on how to do this differentiating by or implicitly, implicit differentiation. A little bit of practice on that. Okay, that's it for me. Hopefully you're getting something out of this. If you will, you can subscribe. Would like that. If you don't want to subscribe, that's okay. But I would like to encourage you to subscribe. And if you like to make a comment about this, please feel free to make a comment. As always, if you think of a better way, show me. But still, again, always be correct when you do that. And that's only fair to do that, right? So anyway, I always like to give you my best so you can be at your best. KP the Math G signing off. Have a great day. Oh, that wasn't good enough. Let's do it again. Have a great day. Ow. Okay, better.